All right, we're recording in progress. We'll go back to share the screen. And here we are. Okay, so just talk quickly about the test. So we've had our first test. All the tests are kind of like that. You should have gotten an email back from me about your exam score. If you didn't get that from me, then let me know. I also sent the solutions video, so you have a chance to check your solutions video. My grading scale is 90, 80, 70, 60. So 90% is an A, 80% is B, 70% is C, 60% is a D, less than 60 is failing. And if you're down by 1%, something in the nines, that would be a minus grade. So that means 89% would be an A minus, 79% would be a B minus. We're actually not allowed to give C minuses, but anyway, that's that. Then another step down would be the lower grade with a plus. So that means 88% would be a B plus, 78% would be a C plus, and so on. Okay, so that's the way you should interpret the grades. There were 10 questions, 10 times 10 is 100, 10 points each for any individual question. Okay, so you should have gotten that score. And a reminder, some of you did not submit any homework. So if you didn't submit any homework, I don't grade your exam and it counts as a 0. And some of you didn't show me your ID. So again, I said, I can't grade your exam if I don't see your ID. How do I know what you look like? Again, for a class like this, I don't really get to know what you look like. So I have your ID saying, hey, this ID and the person who's taking the test, they're not the same person. What's going on here, right? Okay, so I need to know what you look like. Again, if we were meeting face-to-face, we'd be meeting every day, Monday through Friday. After a while, I get to know what everybody looks like. But for a class like this, I don't get to know what everybody looks like. So that's why I insisted on you showing me your photo ID. All right, so that's out of the way. And the next exam is coming pretty quickly, a warning. Okay, it's only the 17th, which is next Friday, I guess. All right, so we're here. So it's a very short chapter, 2.2, 3, 4, and 5. Again, what about 2.1? How come I'm not doing any problems in 2.1? Because there are no homework problems in 2.1. And there's no homework problems in 3.1 or 1.1 or 4.1. They're just a so-called introduction. So you can read it or not. And notice the end of 2.1, there's no homework problems, right? So that's why we start really with section 2 of every chapter. And get this thing focused. So 2.2 on other common functions, okay? So we're here. The next exam coverage is chapter 2. So that's all, quote unquote. So the next exam, now that you've seen one exam, you know how they're all like. So you turn in this stuff for a week from Friday, right? So you turn this in on the 17th, was it? Yeah, Friday the 17th. This is what you're responsible for. You get one formula sheet, blah, 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 same old stuff as before. Everybody has to join. So again, some of you are here synchronously with me right now. Some of you are not, okay? But you have to show up on this day, right? So these are optional, but you have to show up here. And then again, optional, but you have to show up for exams and so on, right? So that's the way it works in general. Okay, let's see. Some question about the ID. Okay, somebody asked me about the ID. Can you send me an email about that? I can probably check on it a little bit later. Okay, so, but if you got a score, if you got an email me, if you got an email back from me with a score, then that means I got your ID. That's fine. And you don't have to send it to me every time, of course. Just send it to me once, I got it. And that's that. So if you got a score back, like my score was, I don't know, 95, 90, 85, 80, that's good. Otherwise, I would have said, hey, I can't grade your exam because you didn't show me an ID. So if you got an email back that I did not get your ID, then you know it. But if you got a real score, then that means I got your ID and you're good. Okay. All right, so that's what we're up against. So this Friday, quiz, Friday the 17th is our next exam. Okay. All right. And so let's see, the quiz on Friday will most likely be 2.2, 2.3 material. And so, remember, it's already Tuesday. It's not Monday. I know in my brain, I kind of think it's Monday because it's the first day of the week because we had a holiday, but it's already Tuesday, right? I'll digress a moment for one nice thing about 3-day weekends, like the Labor Day holiday. You know how it is when you got to go back to school or work, right? You say, oh man, the weekend's over. I got to go back to school or work or whatever. Yeah, but it's already Tuesday. It's not Monday. So when you go back, it isn't you have a 3-day weekend and then you have 5 days, right? It's a 3-day weekend, but you only have 4 days. So it's only 4 days until the next weekend because it's already Tuesday. I don't know. Does that make any sense to any of you? Okay. So I always took it, oh, we have a 3-day weekend. Oh man, I got to go back to school. I got to go back to work. Yeah, but it's already Tuesday. So it's only 4 days, not 5 days until the next weekend. Right. So you can take it or leave it. But the other nice thing about a 3-day weekend is even when you have to go back, it's only 4 more days until the next weekend, right? It's not 3-day weekend and then 5 days. It's 3-day weekend and then only 4 days. So that's it. So it's the gift that keeps on giving, in my opinion, so to speak. Where I always had that attitude, oh, 3-day weekend, that's nice. And so, oh, I got to go back. Oh, too bad the weekend's over. Yeah, but it's only 4 more days until the next weekend. So anyway, I'm just blabbing for nothing, but that's my attitude for 3-day weekends. That was a shorter time to the next weekend. Okay, so let's finally do some math.
Professor, I have
Other
a
common
question.
functions that we have. Okay, so the absolute value function you want to get somewhat comfortable with. Okay, absolute value of x, it's defined to be the same as x if x is greater than or equal to 0. We know that. Okay, so the absolute value of 5 is 5. Absolute value of 21 is 21. Absolute value of pi is pi. Absolute value of 0 is 0. Okay. But if you give me a negative number, the absolute value is the opposite of the number. Okay, so the absolute value of -7 is +7. Absolute value of -1,000,000 is +1,000,000. So what are you doing? You're taking the opposite of the number that was given. So absolute value of x is -x if x is less than 0, right? Okay, and here's the graph of the absolute value function. It's a V shape. I think it's worth memorizing, but again, since you're allowed one cheat sheet, you can put this on your cheat sheet if you wish, but this is what the absolute value function looks like. Okay. All right, and what does it say over here? Well, these are our translation rules that we had before, right? Y equals absolute value of x. Y equals absolute value of x minus 1 minus 2. So do you recall the effect? If I change x to x minus 1, that moves the graph 1 unit to the right, and the -2 shifts 2 down, right? So what they're trying to show you right here is if you can imagine that blue graph is the original graph. And then this thing is 1 to the right, 2 down. So the one that's in red, I don't know if you can tell it's red, but it's absolute value of x minus 1 shifts 1 to the right. And then the -2 shoves the whole graph 2 down. So they're trying to show you a blow up of these 3 here. So, but you can just do it all in one fell swoop. So the absolute value of x goes through the origin. And then when they go like that, right, x gets replaced by x minus 1, move 1 to the right. And then the -2 means 2 units down. Okay. Okay, and let's see. The question about buffer day. Buffer day is just in case I fall behind. So it's not a holiday per se. It's just an extra day. Okay. I'm required by the school to put down the schedule for the whole semester. I almost never keep it. Okay, most instructors don't either. Right? I get ahead, I fall behind, I get sick, my internet goes down or whatever, right? Then the schedule isn't kept. So that's why I have built-in buffer days in case I fall behind or something went wrong or I got sick, then I can cover this up. Okay, so that's what buffer days are all about. Okay, so absolute value function, V shape. Okay. Here's something else I want to show you. Okay, absolute value of x to absolute value of x. Okay, so right here, if I plug in 1, I get 1. Here, if I plug in 1, I get 2. So instead of 1, 1, it's 1, 2. So to have a coefficient bigger than 1, like 2, it moves the graph like so. Right? Makes it more narrow, like that. And then they have here, I don't know if you can see that, page 86, absolute value of 2x minus 1. Well, that just takes this graph and moves 1 over, it moves over to the right. Okay, half a unit actually, right here. And if you put a negative in front, we know that if you put a negative in front, that's a reflection across the x-axis. Okay, the other function I want you to be familiar with is the square root function. Square root function generally goes something like this. They only give me the first quadrant, and there's a good reason for that. You can't take the square root of a negative, and the answer that comes back cannot be negative. So first quadrant is good enough. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. 1, 2, 3, 4, 1, 2. Square root of 9 is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So it curves like so. Y equals square root of x. And once again, you can do all kinds of stuff to it. Square root of x minus 2 shoves the graph 2 to the right. Square root of x minus 2 minus 1, go down 1 unit. So here's the original square root function. Square root of x minus 2 minus 1, that moves 2 to the right, 1 down. So I just draw the basic graph like so. Okay. Square root of x. Reflect across the y-axis, negative square root of x. And you have other varieties here. Negative square root of x plus 2, move 2 to the left. Subtract 1, move down 1, and so on. All right, so you have all these variations on that theme that we've seen before. So this is a basic square root function. All right, so I'll get started with some of the homework problems. There's a much harder problem, the greatest integer function. It's on page 89. So depending on how much time I have, what time is it now? Okay, I may do some today, but not much. Okay, greatest integer function, sometimes called the Floor function. You write it like this. Some books make it like this. And this is actually what I'm more used to. Like that. And sometimes even with double brackets. This is sometimes thought of as the rounding down function. Okay, greatest integer function. So if you already have an integer, the greatest integer function stays the same. For any fraction or decimal part, you always round down. You go down. You don't round off. You always go down for the greatest integer function. So the greatest integer function of 1.2 is 1. Greatest integer function of negative 1.51, you go down to negative 2. If you already have an integer, like 2, greatest integer is 2. Greatest integer function on 0.33 is just 0. So you always round down, so to speak. And this is what the graph looks like. Okay. Sometimes called a step function. As you can see, it looks like I'm going up steps. And so on. And again, if you want to put this on your cheat sheet, you may. What this illustrating is, if you already have an integer, the greatest integer function leaves it alone. So the greatest integer function of 0 is 0, 1 is 1, 2 is 2, negative 1 is negative 1, negative 2 is negative 2, and so on. What's going on here? This interval between 0 and 1, greatest integer function on 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.99, 0.9999999. All of those will round down to 0 That's why the y coordinate is 0. But once you hit 1, it jumps up to the next level. And then 1.1, 1.2, 1.3, 1.9, 1.99, 1.99999. Those all give a function value of 1. And then once you reach 2, it jumps up again. So this is what the greatest integer function looks like. All right, so we'll look more at it later, but I'm going to get started with some of the homework problems. Okay, so our assignment was 2.2 on page 91. On the 37 odd. And again, here it is for those of you that don't have the book, and I'm planning on getting it. Page 91. Okay, so that's up to about 25-ish. So it's further down. Okay, that's the rest of that. Okay, the next page, we have to go up to 37. So, oops. 33, 35, and then 37 looks like a word problem. And there we go. Okay. Okay, so 2.2, ignore the date that's here. Although in this case, it's pretty close. So I'm trying to set you up with problem 5, which is -2 absolute value of x. Okay, so I'm going to start with the absolute value function. Okay, I've got a lot of things going on here, but this one that I'm tracing out is absolute value of x. We put a 2 in front, 2 absolute value of x. It's this one. It goes to infinity faster, so to speak. So if absolute value of x, v-shape, 2 absolute value of x makes it narrower like that. And then -2 absolute value of x, take 2 absolute value of x, so this one that I'm tracing, reflect across the x-axis. And that's the one that you have down here. Okay? So this one is -2 absolute value of x. All right, number 7. -3 absolute value of x minus 1 plus 1. Okay, so I'll show you the progression. Okay, I started off with absolute value of x. -3 absolute value of x. Okay, so we know +3, make it go like this, right? Start off with absolute value of x. It goes up at a 45-degree angle. Okay? Then if you put a coefficient of 3, it makes it narrower. And then a negative reflects across the x-axis. So -3 absolute value of x is right here. And now what does this do? This moves 1 to the right, 1 up. Okay, so this maximum point, it's not really a vertex, but if you want to call it a vertex, I guess. Okay, 0, 0 becomes 1, 1, and I just draw the same shape. So this upside down V, just move it over to there and draw the same thing. So it's 1, 1. So right 1, up 1. So this thing right here, it's in green, although I don't know if you can see it green on the video, but -3 absolute value of x minus 1 plus 1. Okay, so a lot of these you just have to think of, what the root is for these. Okay, 13. G of x is negative square root of x plus 2. So let me show you the progression that I did here. Here's square root of x. square root of x plus 2. Move the graph 2 units to the left. Looks like this. So 0, 0 becomes negative 2, 0. By the way, what do you get when you plug in negative 2? 0. So this is square root of x plus 2. And now what does a negative do? Well, the positive numbers become negative. So that takes this red graph, reflects across the x-axis, and it bounces down to here. You should be able to show me this kind of progression. Okay. Original square root, square root of x plus 2, move to the left, put a negative in front of the whole thing, brings it down. It reflects across the x-axis. So here is negative square root of x plus 2. Okay, the next one I was going to show you is this. How does f of negative x compare to the original f of x? Okay. Do we need to sketch the original one? If it asks for this progression, you should. Okay. You should be able to show me the progression. Okay, here's my original absolute value function or square root function, and then I move it left, right, up or down, or reflector or whatnot. Okay.
Oh, do you want us to show the progression on the homework though, or can we just do the final answer?
On the homework, okay, if you kind of get to the point where you've done so many of them and you get the gist of it, that's fine. But on quizzes and exams, I definitely want to see the progression. Okay. I mean,
Okay.
Some of you have graphing calculators. You can just punch it in the graphing calculator. I don't know what's going on. I just punch it in and there's my calculator. I want you to be able to think and show me, how these things come to pass. Okay. I mean, ideally, you should be able to have no graphing calculator. In fact, I guess the language I want to say is, I wish there were no graphing calculators for some of these problems. Now, graphing calculators are out there, they're readily available, right? But I want you to be able to show me the math, not just punch some buttons in your calculator and voila, the calculator gives me everything and I don't know what's going on. I want you to be able to think about it.
I mean, if we were to just like write out to the left, if we wrote out like left 2 and down 1, would that be sufficient, or do you want us to actually graph it all out?
Okay, so left 2 and down 1 or whatever. You don't actually have to write the words if you don't want to. If you just show me that, I'll know what you did. It's
Okay.
obvious. If you moved it 4 left and 1 down, I know what you did. You don't have to say it if that's what you mean. Unless the problem specifically says, what happens when I do blah, blah, blah. Okay, and you see, oh yeah, parentheses, x minus 4, or move 4 to the right. And then if you see minus 3, oh, okay, I moved 3 down or whatnot. But otherwise, you don't have to write it out in general, if that's what you mean. All right, how does f of negative x in general compare to the original f of x? Okay. So suppose f of 1 is 0, and suppose f of 2 is 3. So where did you get that from? I just made it up. Suppose the graph looks like this. F of 1 is 0, f of 2 is 3. F of negative x, if I plug in negative 1, I'm doing f of negative 1, which is positive 1, which is also 0. And for this function, if I plug in negative 2, I'll be doing f of negative 2, which is f of 2, which I know is 3. Okay, so it's going to end up reflecting across the y-axis. Okay, so again, if you want to put this in your cheat sheet, you may. The graph of f of negative x reflects f of x across the y-axis. So f of negative x reflects f of x across the y-axis. All right. How is that going to help me for something like 15? G of x is square root of 2 minus x minus 1. This one's a little tricky because it's not 2 minus x, it's 2 minus x, but the formulas are usually in terms of x minus 2. So I do a little bit algebra trick. Algebra trick is the opposite of 2 minus x is x minus 2. So I want you to realize that these two are the same. Okay, the negative of x minus 2, well, distribute. You get negative x minus a minus 2 or plus 2. So it's negative x plus 2, which is the same thing as 2 minus x. All right, so here's the progression. I go from square root of x to that to negative that, and then minus 1. Okay, so I've got all these functions here going on. All right, so here's the original square root of x. Square root of x minus 2. Move 2 to the right, not 2 to the left. Double check. What happens when you plug in 2? 2 minus 2 is 0. Square root of 0 is 0. But if I had moved 2 to the left, that would be negative 2 comma 0. But if you plug in negative 2, you don't get 0. In fact, it would be undefined. So this is square root of x minus 2. Now, if I put negative parentheses the whole thing, negative in front of the whole thing, that's an instance of this. That reflects across the y-axis. So now, this graph, this thing reflects across the y-axis. It ends up going like that. So that now is square root of negative x minus 2, which is the same thing as square root of 2 minus x, because that's the way it was written in the original problem. This is negative 2, 0. And now I'm home free. What happens to the negative 1? Go down 1 unit. So here's negative 2, negative 1. And the graph looks like this. So here's my final answer. This graph in green, not sure if you can see that it's green, but that's it. Square root of 2 minus x minus 1. Because this is the same thing as square root of negative parentheses x minus 2, but I needed to do this little trick to show you how the progression works. Square root of 2 minus x minus 1. Okay, a little bit more on absolute value. So starting with problem 19. Absolute value of a graph. Our basic absolute value function looks like this, V shape. Well, we could start off with our basic just y equals x. Now, if I take just y equals x, I'm going to write in the book a little. Y equals x looks like this, right? Straight line, slope of 1, goes up at a 45-degree angle. As soon as I see absolute value of x or absolute value of anything, I can no longer have anything in quadrants 3 and 4. Cover it up, shut it out completely, right? In quadrants 3 and 4, y is negative. But once you see the bars, right, absolute value of whatever, I cannot have anything in quadrants 3 and 4. So here's another way of thinking of the absolute value of x. This is just x, right? Now, absolute value of x is the same thing as x if x is greater than or equal to 0. Which means any part that's already above the x-axis stays the same. So this part of y equals x is y equals x, right? This part right here, just this part, is above the x-axis. Keep it the same. Graphically, that means absolute value of 1 is 1, absolute value of 2 is 2, absolute value of 3 is 3, absolute value of a million is a million. That part stays the same. Because the absolute value of a positive is positive, and the absolute value of 0 is 0. Now, What do I do with the part that's below the x-axis? You know I can't stay there. Well, the absolute value of -1 is +1. Absolute value of -2 is +2. So all the ones that were negative become positive. So the part that's below the x-axis, only focus on this right now. This part here, quadrants 2 and 3, you reflect across the x-axis. So this thing bounces over here. Take the mirror image, the reflection of this part down here in quadrant 3 reflects over to quadrant 2, and that's why you end up with this graph. That's going to be true in general for absolute value of anything. Sketch the graph of absolute value, blah, 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 blah. Okay, first they graph the parabola. You can complete the square, or you could do the vertex formula. Vertex is at -b/2a and so on. It's a parabola opening up. So here is x² minus 4x plus 3. You can plot points, you can get the vertex. The vertex is at 2, -1. You can either get that by completing the square or just do the -b/2a stuff. Now, how do they get this? Absolute value of all this stuff, same principle. Anything already above the x-axis stays the same, because all of these guys here are positive, right? The y value is positive, absolute value of positive stays positive, so that part stays the same. Maybe I'll trace this with my 2 pens. This part stays the same. This part stays the same. I know, over like this. Right there. Completely identical. But for the part that's below the x-axis, right? This part down here, you know the answer can't come up to be negative. So if I plug in 2, you get -1. But what's the absolute value of -1? +1. It jumps over to here. So this part right here, put a mirror image right there. This U shape becomes upside down U shape, and that comes over here. Okay, so this part right here ends up going like this. So again, the stuff that's above the x-axis, this stays the same. This stays the same. The part that's below the x-axis reflect so that it comes up. So this thing bounces over to like that. So I end up with this funny looking W shape right here. Okay, so example. 19. Sketch f of x and absolute value of f of x. F of x equals 2x minus 3. So f of x equals 2x minus 3. Rise over the run is 2. Y-intercept is -3. Put on -3. Slope is 2 over 1 up 2 over 1 up 2. So there's f. Now, absolute value of f. Anything that's above the x-axis stays the same. The part that's below the x-axis reflect. But then you put a mirror here, the mirror image ends up like that. And yes, it's a modified V shape. It's not the same as the true V shape, but it got narrower, but still V shape. So the final answer is this V. Okay. So again, I take the original 2x minus 3. Anything above the x-axis stays the same. The part that's below the x-axis reflects across the x-axis and comes over here. So that's my shape. Okay, 23. Negative parentheses x minus 1 squared plus 1. Graph f and absolute value of f. Okay, I know what x squared looks like. Negative x squared opens down. And what about these two? 1 to the right, 1 up. So the vertex, which used to be 0, 0, is now at 1, 1. Okay. So the original function looks like this. Now, absolute value of f. The part that was above stays the same. So this upside down U sheet stays the same. But anything below bounces up. So this thing that used to go down, reflect across the x-axis, it goes like that. This part that used to be below also reflects across the x-axis, bounces up. So I have this funny looking W, like that. Remember, for absolute value functions, the final answer cannot have anything below the x-axis, nothing in quadrants 3 and 4. If all you're asking for is the absolute value of the whole thing. Okay. If we do this type of question, should we use different colored pen? It's up to you. It makes it nicer. I try to do a different colored pen, but I'm noticing it doesn't quite come out. But I'm not requiring you to have different colored pens. If you just show me the progression, I'll know what you did. But it might be easier to keep track just for your own benefit. I mean, it helps me when I see the different colored pens and so forth. Okay. All right, last thing I was going to do for today is go back and talk about domains. I intentionally didn't do any domains, but now that we have the graphs, we'll go to it. So find a domain and range of each of the functions. Okay, so let me go back to 13, negative square root of x plus 2. So this was the graph, right? So domain, I got nothing over here. I have negative 2 all the way to infinity. So bracket negative 2 comma infinity. Range, well, I have all the negative numbers I want. I have 0 and nothing above. So the range is parenthesis negative infinity comma 0 bracket. Okay, so again, the graph is this. So you're at negative 2 and you're going all the way out to infinity. For the range, you have all the negative numbers. You go up to 0, including 0, but nothing above. So parenthesis negative infinity comma 0 bracket. And finally, domain and range of 15. So the graph was like this. So I can go negative infinity up to negative 2, but nothing beyond negative 2, including negative 2. So parenthesis negative infinity comma negative 2 bracket is a domain. And what's my range? See, I start at negative 1, include negative 1, and I go as high as I want. So bracket negative 1 infinity. Right? So domain and range of 13, domain and range of 15. And that was as much as I was going to cover for today, folks. Cool. So I'll let you ask questions now if you have any, but if not, that's about it. Okay, so we are now up to here, 2.2. I'll do more 2.2 and maybe start some with 2.3 tomorrow. Yes, question.
It's not so much a question, but I know tomorrow you're going to continue going over problems, and I just like to request to go over 35.
Over 35? Okay, I might get to that. So if you're already there, great. That means you're ahead. Let's see. Get to, whoops. Get to that. Okay, we'll see. It might be one of those questions where I decide to throw something out also, but
yeah, that's kind of what I was thinking. That's why I asked. So yeah, yay, yeah.
Okay, yeah, we'll get to it, I think. Okay.
Professor, I've got a question as well.
Yeah.
I was just wondering if you could go over like completing the square. Like for 25, we were gonna have to complete the square. So I'm just confused about when you expand the x squared minus uh, integer x, and then you like add,
Mhm.
I guess, yeah.
Okay, well, there's some time for that. Let's see. Okay, so how does completing the square work? X squared minus 6x plus 7. Okay, so I need half the coefficient of x and then let's square it. So half of -6, -3, square it, 9. Okay, so remember it's half square. So plus 9 to balance it, -9. So this now factors into x minus 3 squared minus 2. And there it is. So I know the vertex is at 3, oops, 3 -2, because this is a translation of the vertex 3 to the right and 2 down. So my vertex is at 3 -2. So very crudely, 1, 2, 3, 1, 2. I know it opens up. So something like that.
Okay, thank you. And then is there ever any possibility that you would like add 9 and add 9, or subtract 9 and
So we
subtract?
add 9 and add 9. That would be the case if we have a negative in front of the whole thing.
Okay.
So this is not an actual problem, but if we had negative x squared minus 6x plus 7, okay, by completing the square, plus 9, but when I put plus 9, it's really a subtraction of 9. So that would be the case where I would go ahead and add 9 because I'm distributing the negative. So that would be, negative x squared plus 16 or whatever. So that would be such a case.
Okay, thank you.
Okay. All right, welcome.
Also, now that I'm looking at it, 37 was really hard, and it was very confusing. I mean, it was confusing for me. Like, I kind of got it, but if we could go over that too, that'd be cool.
Okay, we'll see. I'll see if I have it
Yeah.
on the docket offhand, but yeah.
Okay.
All right. So 37 is a practical example of the greatest integer function for postage, right? So, there's a certain amount of postage you have for 1 ounce, 2 ounce, 3 ounce. And it's the same if you have 1 ounce or 1.2 or 1.3 or 1.4 or 1.9, right? Then, and then once you get to 2, then you have to jump up. When you park in a parking lot, that often is the case, right? When you go to the parking garage, right? It says, 0 to 1 hours, you pay this, and then 1 to 2, you pay this, and 2 to 3. So how you go, I'm at 1.5, 1.8, 1.9, right? So I got to get my car out before the 2, because once it hits the 2, then you got to go up again, right? So that's another example.
Because they want us to graph it. That's why I was particularly getting confused. So would the greatest integer part of the graph stop at 1 and not 0? Like, I mean, like,
yeah, it looks like greatest integer function differs depending on where you're at. So yeah, we'll talk about it.
Okay,
Maybe
all right.
tomorrow.
Okay.
It depends if we have time, if I finish it even by tomorrow, but we'll see.
Okay.
Okay. Whoops. Okay, let me stop the share so I can see the chat. All right, I think I caught up with the chat. Okay, anybody else with a question, please? Otherwise, we'll call it a day. All right, that's it then. Okay, folks, so have a good day and we'll see you next time. Okay,
Thank
all
you,
right, bye,
Professor.
everybody. Thank you.
Thank you.
Bye.